Okay, so I hope you went to the evaluating functions video and watched that just to get better at evaluating functions. But we're still on the notes page called Finding the Domain of a Function Symbolically, and so we are going to talk again about domain and range, and then we're going to find the domain not with a graph but given a function. Okay, so the domain, again, it's the set of x coordinates, also known as the input or independent variable. So this first example, the domain of a function is the set of all inputs for the function. The domain of a function may be stated explicitly. So here is a function, f of x equals x squared, and that actually is a parabola, just to sort of make connections. So that's what the graph of that would look like. And it's saying that x has to be between 0 and 5. Okay? Normally, the domain of f of x equals x squared is all real numbers because it goes on and on to the left and right forever and ever. But here I'm stating the domain explicitly. Okay, so sometimes we do that and it makes people think this is a hard problem, but really I'm telling you what the domain is. So we need to put an interval notation. This means that 0 is included in the domain because of the equal sign, and 5 is included in the domain. So the domain for this problem stated explicitly is from 0 to 5. So what that would mean is the graph of this would only look like this piece from here to here, like that. The range is the set of y coordinates in a relation, and it's known as the output or dependent variable. It's called the dependent variable because it depends on the independent variable. So the range actually depends on the domain. So it's a little harder to find because you have to plug in the smallest x value. If you plug it in, f of 0 equals 0 squared is 0. So when x is 0, y is 0. And then the largest x that you could put in is 5. So if you put in f of 5, you get 5 squared, which is 25. Now it's a little more complicated than that, but normally not. The reason that I can plug this small value in and get the smallest y value and this large value in, get the largest value, is because I know what the function looks like. It's an increasing function, so that's going to be true. But the point is that the range depends on the domain. So it's always a little harder to find. You have to do some evaluating. But the good news is we're going to concentrate on just finding the domain. All right, so when a function is given without a specific domain, the natural domain of the function is the set of all real numbers for which the outputs of the function are real numbers. So again, given a function, the domain is all the x coordinates that have a y coordinate partner. Okay? And when we're doing this symbolically, there are 3 important restrictions on the domain that you have to memorize, and it's really just memorization. So the first one is you're going to need to know, given a rational function, a variable in the denominator is never allowed to equal 0, because if you try to put in 5, for example, divided by 0, turn the calculator on, your calculator is going to say divide by 0 error. That's not a number. Okay, so you can't have 0 in the bottom of a fraction. So if you're given a function and I say find the domain, you have to analyze. You have to say, oh, that's a rational function. You don't have to know the name of it. We want you to know the name of it. But the idea is, oh, this has a denominator, and that denominator can't equal 0. We're not saying that x can't be 0. X could be 0. 0 minus 2 is negative 2. That's okay. But the denominator can't be 0. So if I ask you to find the domain in interval notation, the first thing you have to do is look at the function and say, oh, this denominator, which is x minus 2, cannot equal 0. And then you have to solve for x. So we're going to add 2 to both sides and find out that x cannot equal 2. Now this is an easy one, so you may have been able to figure that out in your head, which is good. X cannot be 2. Okay, so what is it that X can be? So we're trying to find the domain. That means X can be everything but 2. And so we have to write this in interval notation. So from left to right, what's the smallest number ever? Negative infinity. All of these numbers are in the domain until you get to 2, parentheses. That means that 1.9999999 is in the domain, but 2 isn't. Union, parentheses 2 to infinity. That's interval notation for X cannot equal 2. X can be any number from negative infinity to 2, union 2 to infinity. So you have to memorize that. When I ask you to find the domain, number 1, the domain cannot equal 0. Okay, the second thing that you have to memorize is given a radical function. That means it's a function under a radical sign. Okay, with even indices, given a radical function with even indices. So let me take a time out. Let me explain that. So if you see something like this, you know that, right? That's the square root of 9, and the square root of 9 is 3. That's not what I'm worried about. What I want to tell you is that the number that's right here is understood. It's a 2. That's called the index. And you won't see it because it's so common for the index to be 2. So if you don't see a number, it's called the square root, and that index is 2. You might have something like that, a 4 in there. That means the fourth root of 81. And that means what times what times what times what? What number times itself 4 times will give you 81. Your calculator will give you, but that's also 3. Okay, so these are what we call indices. That's plural for index, and these are even. Okay, you could also have an odd index, like the cube root of 8. And that means what times what times what? What number times itself 3 times gives you 8? Well, that's 2. But here's the weird thing. The cube root of negative 8, what number times itself 3 times gives you negative 8? Well, consider negative 2. Negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is 4. And then 4 times negative 2 is negative 8. So what we find out that is that if you have an odd index, it can be a negative under a radical. But if you have an even index, like the square root of negative 9, there is no number times itself that's going to give you negative 9. There is no real number. Now some of you may have heard about imaginary numbers. We're just talking about real numbers when we're talking about the domain. So there is no number. 3 times 3 is 9. That's not negative 9. Negative 3 times negative 3 is 9. That's not negative 9. So this doesn't exist. Okay, so all that to help you understand this. Given a radical function with even indices, okay, like a 2 or a 4, the expression under that radical has to be greater than or equal to 0. It can't be negative. See? Can't be negative. Now, it can, if it's an odd index, it can be negative. So this is the rule only for radical functions with even indices. Okay, so let's say you have that memorized, and I give you this problem. Find the domain in interval notation for the given function g of x equals the square root, understood 2 is an index, square root of x plus 5. I'm not trying to solve the function. I'm trying to find the domain of the function. I'm trying to find the x coordinates that have y coordinate partners. So I have to have this memorized. The expression under the radical has to be greater than or equal to 0. So what I'm going to do is take the expression under the radical, which is x plus 5, and make it greater than or equal to 0. So I'm analyzing. So people get confused because they're like, where did the square root go? And the square root isn't around because I'm not trying to solve the function. I'm trying to analyze its domain. And I know that what's under the radical has to be greater than or equal to 0. So if I subtract 5 from both sides, I get x is greater than or equal to negative 5. So that tells me the domain. It's saying that all the numbers in the domain have to be greater than or equal to -5. Now it says put it in. So that would be, the smallest number would be -5 with a bracket because it gets to be included all the way to infinity. Okay, now check your work. Is this true? If we put -5 in here, -5 plus 5 is 0. The square root of 0 is 0. So 0, 0 is an ordered pair in this function. That means, -5, 0 is an ordered pair in this function. So that means that -5 is in the domain. If you put in -4, -3, -2, you would get values. But if you tried to put in like -6, if you put -6 in here, -6 plus 5 is -1, and there is no number, real number, square root of -1. So these are the values in the domain. Okay, now I've added this problem to see if you understand how to find the domain of this very complicated function. Now we could graph that in Desmos. I don't really know what it would look like, but it would look weird. It's a rational function added to a square root function. Okay, but it doesn't really matter. We can still use these two rules that we have memorized. If I ask you to find a domain, I have to look for these two things. Is there a denominator? Yeah. So I know that x minus 2 cannot equal 0 because I know that the denominator here cannot equal 0. And we've already done that, but we'll do it again. That means x cannot be 2. And we have a radical, an even index radical. So I know that what's under a radical must be greater than or equal to 0. So x plus 5 has to be greater than or equal to 0. We've already done that. So these two things have to be true. So if you watch the video on interval notation practice, then you remember that we're going to draw two graphs. All right, x cannot be 2 means that it can be anything but 2. So this is what x cannot be 2 looks like. And then x is greater than or equal to -5 means that it can be -5 and anything to the right of it. All right. So what would the domain be? Well, both of these things have to be true. So x can't be anything lower than -5, but it also can't be 2. So if you put it together, you get this graph. And remember, graphing is a good way to get the interval notation correct, because I'm not going to accept this answer. It has to be an interval notation. So this is the graph of both of these things. And what does this graph look like? Well, that starts out at bracket -5, and it goes to 2, but it has to hop over 2, and then it goes to infinity. So this is the domain of this function here. Any number greater than or equal to -5 except for 2 is what it's saying. All right, now the third condition, I used to not have this, but I've added it. It's a combination of these two. So you could, if you memorize just these two, you could get this one right with critical thinking, but I've added it as a third rule to help students. What if you have a radical function with even indices, but that radical function is in the denominator? Okay, if you have that, a radical in the denominator with even indices, then the expression under the radical has to be greater than 0. Okay, if it's just under a radical, it can be greater than or equal to 0, but this says greater than 0. Well, that's because it's in the denominator. So remember, in the denominator it can't equal 0, so that's why that equal to isn't there. Okay, so if I gave you this function, f of x equals x plus 6 is greater than, over the square root of x minus 3, then you pull out the x minus 3 into the radical, and it can't be negative, so it has to be greater than 0, and it cannot equal 0, so we'll just leave that part off. So that means that if we add 3 to both sides, x has to be greater than 3. So the domain, all the x coordinates that are going to have y coordinate partners are parentheses from 3 to infinity. Okay, so we can check it. If we tried to put 3 in, 3 minus 3 is 0. The square root of 0 is 0. That's okay, but 9 over 0 is not a number, so you can't include 3. But you can include 4 or 5 or anything greater than 3, and it will be fine. Alright, so I'm going to let you try these, so you might want to pause the video and try them. And if this were a seated class, I would say this is really important. It's important for you to actually get things wrong sometimes so that you can correct your error before the test or the quiz. Alright, and we always want to use pencil so we can erase. Alright? Okay, so I'm going to go ahead and start. So f of x is equal to the square root of 7 minus x. Well, I want to read the directions, and the directions are not to solve, they're to find the domain. So we have to do some analysis. So this is a radical function, and we have it memorized. Anytime you have an even index radical, what's under the radical has to be greater than or equal to 0. So I just write that down. What's under the radical is 7 minus 2x. It has to be greater than or equal to 0. Alright, now I have to know how to solve for x. So these are two terms, and I want to get rid of the term that doesn't have the x first. So I'm going to do that by subtracting 7 from both sides. So if I do that, I'm left with negative 2x is greater than or equal to negative 7. Okay. So now I want to get rid of negative 2 times x. So the way I get rid of times is division. You always undo what's being done to x, and to undo times you divide. So I'm going to divide both sides by negative 2 because whatever I do to one side I do the other. So this part is going to work. That's x. But this is really important, so I put this example here. Do you remember this rule about inequalities? When you multiply or divide by a negative number, you have to switch the inequality signs. So we got to do this little review of algebra. So write that down. So when you divide by a negative number, it's going to change the direction of this inequality. So this is actually going to become x is less than or equal to, and then a negative divided by negative is a positive 7/2. Okay, it's real simple why that works. Just to help you remember this, let's say I have this true statement. Is 3 less than 8? Sure is. But if I multiply both sides by negative 1, is negative 3 less than negative 8? No, it is not. So when you multiply or divide by a negative number with an inequality, you have to remember to switch the inequality signs. Alright, now last thing is, this is the domain, but we need to put it in interval notation. So we're talking about all the numbers that are smaller than or equal to 7/2. Remember, you have to go least to greatest. So you have to start with parentheses negative infinity and all the numbers up to 7/2, and you can include 7/2. So we have a bracket. If you forget interval notation, remember you can graph this. This is all the numbers to the left of 7/2. So that's why it's negative infinity to 7/2 bracket. Alright, second example. G of x equals the square root of x plus 2 over x minus 5, and our job is to find the domain. That means find all the x coordinates that are going to work for this function that have y coordinate partners. And you have to have this stuff memorized here. So we have a even index radical. Do you remember what to do there? You have to analyze it and say, well, that's okay, but x plus 2 is going to have to be greater than or equal to 0. And you have a denominator, and do you remember that any time you have a denominator it cannot equal 0? So x minus 5 cannot equal 0. So those are the two restrictions on x. If we solve, we get x is greater than or equal to negative 2. And if we solve this one, x cannot equal 5 if I add 5 to both sides. Okay, so those are my restrictions, and I have to put it in interval notation. So I'm going to use a number line. This time I'm just going to draw one number line, and I'll put the key numbers in, -2 and 5. And anytime you have an inequality that's a not equal to, do that first, because that's just going to show up as a whole. X can't be 5. And instead of shading everything, just kind of mentally know it's everything but 5. And then graph this, x is greater than or equal to -2. That's a colored in circle on -2, and it's to the right, and you just remember when you get to 5, skip over it. So you don't have to knock yourself out graphing 3 graphs all the time. Alright, so then in interval notation, this domain is bracket -2, comma 5, parentheses, because 5 is not in the domain, union, parentheses 5, to infinity. So those are 2 examples here. Alright, let's get a little bit more complicated. We have to do some more algebra that is supposed to be reviewed, but may not be. And number 3 is a really important one. It says h of x equals x minus 4 over x squared plus x minus 12. You may want to Google Khan Academy how to factor, or I might even make a video about how to factor my way for you. But let's just dive into this example. So before you can answer this question, you always need to take any kind of quadratic and see if it will factor. Alright, so what in the world does that mean? Well, a quadratic trinomial, x squared term and then an x term and then a constant term, if it factors, it's going to factor into 2 binomials that are multiplied together. Okay, factoring means write as multiplication. So this first part is easy because x squared comes from, if I were to take this x here and that x here into, if I were to multiply that out using the FOIL method, x times x is x squared. Alright, the middle term is a little more complicated, so I'm going to skip over it and I'm going to take a look at this last term. Now this last term comes from whatever's here times whatever's here. Alright, so what you have to do is you have to think of all the factors of 12 and go in order so you don't skip any. 1 times 12, and after 1 you have 2 times 6, and after 2 you have 3 times 4, and that's all of my factors of 12. Now since this is a minus, you have to figure out which one of these subtract to be 1. Okay, so 12 minus 1 is 11, 6 minus 2 is 4, and 4 minus 3 is 1, so that's it. So there's a 3 and a 4. Now, I never do the negatives until the very last step. Okay, I need this to be a positive 1, so I'm subtracting, so one of these has to be negative and one has to be positive. Well, if I want it to be a positive 1, that means the 4 needs to be positive and the 3 needs to be negative. So that's factored. So before I can deal with the domain, I have to factor that quadratic trinomial, which I just did. Now I can do the domain. So remember, if you have a denominator and you're trying to find the domain, the denominator, which is x minus 3 times x plus 4, cannot equal 0. So this is really why I factored it, because to solve a quadratic, you have to factor it. You wouldn't want to add 12 to both sides. That's not how you solve a quadratic. That's how you solve a linear equation. But a quadratic, x squared, you got to factor it. So once you factor it, you set each of these factors not equal to 0. And then x cannot be 3, or x cannot be -4 if I solve for x. Alright, so that looks like this. Here's a -4, here's a 3, and we're saying that x can be any number but these 2 numbers. Can't be -4, can't be 3. So when we put this in interval notation, it happens a lot, so hopefully you'll get used to it. So this domain is from negative infinity to -4, parentheses, -4, to 3, parentheses, union, 3 to infinity. So it's something worth memorizing. If you have two things that can't be, interval notation is going to end up with three intervals. A lot of times people forget that middle interval. Negative infinity and negative 4, but negative 4 to 3 is in the domain, but then 3 to infinity. Alright, so number 4 is one of those combined ones. You have a denominator. Okay, so it cannot equal 0, but you have an even index radical. So the expression under the radical has to be greater than or equal to, nope, just greater than 0 because it can't equal 0 because it's in the denominator. And where did the fourth root go? Well, we're not trying to solve the function, we're trying to analyze the domain. So what's under the radical comes out, and x has to be greater than 5. So the domain here is parentheses 5 to infinity. Okay, so there are some problems in the lab manual for you to practice. I'm just going to go over a couple of these range problems. It says finding the range. Sometimes it helps to find the domain before you find the range, and the reason that is because the range depends on what's in the domain. The y coordinates depend on what the x coordinates are. So range is always a little more complicated, and it really is helpful if you know what the function looks like. So this is just a line, y equals mx plus b. And lines have no restrictions. They go on forever and ever and ever. So this range is all real numbers, just because I know it's a line. Alright, this one, you might want to find the domain first. Okay, so the domain 2 minus x is greater than or equal to 0. Subtract 2, negative x is greater than or equal to negative 2. There's a negative 1 understood, so let's divide by negative 1. And so you get that inequality has to switch because you divided by a negative number. Negative 2 divided by negative 1 is 2. So your domain is all the numbers less than or equal to 2. And if you have memorized what a radical function looks like, you know that it is going to either look like this or like this. And this particular one kind of has that. So it's a decreasing function, and it's a really good thing because now all I have to do is just put these values in. If I want to find the range, well, if I'm going negative infinity, then the range is actually going to, let's put this 2 in. So if we put 2 in, 2 minus 2 is 0, square root of 0 is 0. Okay, so this range is going to start at 0, and now let's put the negative infinity because something weird is happening. 2 minus a negative infinity actually comes 2 plus infinity. So that range is actually going up forever and ever and ever. And you have to put it in the right order. So because it's a decreasing function, that 2 in the domain leads to the smallest range value, and that negative infinity leads to that largest range value. If you have access to Desmos, it's a good idea while you're doing your homework is to graph these things so you can kind of get a good sense of what is happening there. It actually looks like this if you were to graph it. Alright, I think that's all I'm going to do for range, because as we get further on in, we'll talk more about that.